All right, how you guys doing? Welcome back to week 3. Um, you're going to notice this week is a lot like last week as far as what it is you have to do. So we're going to take a quick look. I'll give you a quick rundown of what it is that we're going to take a look at, how to kind of go through it, and then hope to see you at some of the sessions. Remember, one time is mandatory. It's only Wednesday when I'm recording this, a week before. But we did not have very good attendance, and if that's why your participation grade is lower than you want it to be, it's probably for that fact. All right, so what we have is we have hydrates. Hydrate is just going to be a slightly more complex version of doing an empirical formula. Okay, so same thing, discussion board, week 3, I'll look at that. You can post to that. Biggest thing is office hours. Again, remember the changes. Even though there was demand for it, the 2 to 3:30 extra time, there wasn't very many people that came to it. I mean, I'll keep going. It's not like I'm not working on my computer at that time anyways. But for those of you that said, 10 is too close or too early, we need to make use of that time. It's only to your benefit. All right. So we're going to look at this again. I need to change this, so I'll change that before you look at it. But anyways, we're looking at hydrates. So there is I'm going to show you that quick discussion. This video will go here the week ahead. I'll post my explanation of ChemQuest 41. There's only actually three or four new problems now I'm trying to think of. 3 or 4 new problems. We'll look at it anyways, of what that ChemQuest looks like. I will put on an example problem there. You can see the ChemQuest is already loaded. Skills practice. This week's a little bit different. It was kind of like last week, but I didn't get to explain that, where the only one you have to do initially is the ChemQuest, and then you can do the skills practice and lab in any order. So they're there for you. Again, until Thursday, the only questions I'll help you with the skills practice, and as far as questions you may or may not have, and that's a shorter one too. But the ChemQuest is something that we can do every single problem if you want to, even after the answers populate. Most of this ChemQuest you're going to see is actually a little bit of review because some of us need it. And then at the end, there'll be a slightly longer quiz after the morning discussion on Friday. I'll post that up. So that is what our week looks like. Let's look at a couple of topics. So here's your topic that you're talking about. Just trying to get you to think of hydrate. I'm showing you a hydrate and an anhydrate. So you could take a look at those and then what it might look like at the molecular level. So do your best answering those 5 questions. Again, it's not like you have to look anything up. It's a discussion question, post, go from there. Then we have our ChemQuest. I'll do a separate video just rolling through that thing, but you can see there's only 3 questions. That's new, and then there are 6 review questions because after our first question, and then we have some of those on our quiz this week. It'll be a good idea to take a look at it. Skills practice, pretty straightforward, 5 of them. Again, the big thing is in both the ChemQuest and the skills practice to show your work. I don't know if you want to do this before or after, but they kind of start easier, and then 4 and 5 both have a little bit of a trick to them, so just make sure to read them carefully. All right, it's not that you can't do it. They're kind of one-trick ponies. There's just different ways I can word it. And then finally the lab, and again you can do these in any order. The lab is pretty cool. This again would be kind of a fun one that we do in class, and we'd all kind of do the same one. But to make it different, all right, what we got, and I'll explain this a little bit better when I go over the ChemQuest, but what we have is we have our hydrate and hydrous, and then we're having this part water. So what we're taking a look at, the crystal we look at is this guy. It's the combination of them put together in a crystal, and what we're doing is we're separating them, all right? So kind of like a decomp reaction. What you're going to do is everybody is going to watch this video and take data on it, and then you can choose any of these other ones that you want. So there's copper 2 carbonate, cobalt 2 chloride, and sodium thiosulfate. They all are kind of different, kind of cool. You can watch all of them if you want to do more then 1. You could, I guess, I said do 2 because I expected groups of 2. If you want to do a group of 3 and do 3, I guess that'd be fine too. But I want everybody to have to try one of those out. So watch the video. I'm having you create your own data table. So the information I want is here, but you can put it in whatever order you want. So create the data table, probably re-watch to take the data later once your data table is done, but I want you to watch this initially just to kind of see what's going on. Okay, what types of things should I take? And then pick one of these others, you know what to do. Or if you have a group of 3, pick 2 more to do. And then anyways, then you're gonna show me this data. So you're gonna show the formula of the hydrate. If you read the background and you did your ChemQuest, that should be easy. Same thing with the anhydrous salt. The initial mass, again, that's some of your data. The final mass of the anhydrous, again, some of your data. And again, if you've done your skills practice, that is very straightforward, except for just knowing those names and what that means. The final calculation of moles of the anhydrous salt, mass of the water driven off, and then the final calculation of moles of water driven off. All right, we don't want to round that. I'll show you why in a second. So you might get some decimal answer, which you know isn't perfect, but definitely I want you to keep it that way just based on the data. And then your empirical formula, and this was the whole goal that we had throughout anyways. So just make sure that this is going to look like all your other work. Really, this whole lab is what you did in the ChemQuest, what you did in the skills practice. You're just collecting the data, but the work should look the same. All right. So what I want you to do is for the both, or if you're a group of 3, doing your hydrates. So calculate, show the work for all of them. All right. Calculate the percent composition of the mass of water. Okay. So going back to percent composition, what we want divided by the whole. This is why we didn't want to round that answer, even though in your N we don't want to round. But in your goal, your empirical formula will. Because I want you to calculate, okay, what was the experimental error? And then, number 3, what could we do better? And different things like that. And then slightly, how could we use this idea of anhydrous and then rehydration to help us out? So anyways, that's basically the week in a nutshell. Again, once you get done with the ChemQuest early on in the week, you have plenty of the week to work on these, ask questions on the ChemQuest. Again, I will answer questions on the skills practice and lab, but I'm not going to work out any problems until Thursday for the skills practice and the lab. I mean, honestly, if you do the skills practice, I might just have to answer some questions in the lab, but you should be able to turn that in. When you turn these in, ChemQuest, make sure everybody's name on it. Skills practice, that's solo. Same thing with the lab. If you have 1 partner or 2 partners, you can turn in 1 lab. That's why they're not kind of set up that way. And make sure everybody's name on it. Okay. See you in office hours. Hopefully you had a good Easter. Stay safe, and we'll see you later.